Good evening, students. Welcome to Chemistry Bridge class. Uh, Before starting, that is just I want to have one or 2 points. In yesterday's class, we tried to like have discussion of some multiple choice questions based on the topic, that is acids, base, and salt. Now let me go directly. That is first question is, which of the following will, that is the statement of the question is, so they are saying which will turn of these, like whatever this compounds, uh, which of the following will turn, means out of these four given compounds, that is red litmus paper to blue. That is the question statement. Now already that is we have known that suppose if the solution is acidic, if the solution is acidic, then what we are going to observe is it will turns blue litmus to red, blue to red. The color of litmus paper initially will be blue. After adding one drop of this your acid solution, it will turns into red. Suppose if the solution is base, then what is the observation we are going to observe? That is opposite. Red litmus paper will turn into blue. So these are the observations, that is which are, these are the, I can say, one of the properties of this compounds which are acidic and bases. Now based on that one, just if you see the statement, which of these following will turn, that is red litmus paper to blue, means out of the given compound, that must be what you can say red to blue, means it should be what you can say basic in nature. So if you see that options, that is if I'll go with this one, this compound, it is alkali or it is a base. So this will be the answer. Including that, you can check why can't this other, because this compound it is acid, citric acid is acid, and this our carbonic acid is acidic, that's why it cannot. And this is going to be like these three will turn blue litmus paper into red, whereas this first one, magnesium hydroxide, which is alkaline solution or basic solution, so that will turns your what we can say red litmus to blue. So based on that one, for this question, that is question number 1, A is the correct option. A is the correct option. Moving to next. Question number 2. Which of the following will conduct? Now they are asking, the question statement is, which of the following will conduct? Which of the following will conduct? That is they are asking, that is electricity. Already we have known, that is any substance after putting into water, if it has got the property of producing what we can say ions, if they are going to generate ions, then those compounds will be responsible, or they will conduct what we can say electricity. Now based on that one, if you see the given options, if you take glucose, that is the formula of the compound is C6H12O6. When you add into water, of course, now you should be very much careful. After adding into water, that it should produce ions. So this glucose will dissolve in water, but it cannot split into its ions. So that's why this cannot be the answer. This will dissolve into water. Now similar way, this ethanol, that is ethyl alcohol solution, means that when we add into water, it will produce its solution, but it cannot ionize. Now suppose if I'll take this another, whatever third option they have given, acetic acid. Acetic acid formula is this one, CS3 COOH. So this compound, when you add water, it will dissociate into which are the ions? CH3 COO minus plus H plus. Now this compound, after adding into water, it will dissociate into its ion, means it is going to produce what we can say in aqueous solution in water, ions. So ions, if they are producing, they are responsible for conducting, that's where what we can say electricity. So based on that one, this acetic acid it is going to be the correct option. Now why can't this were HCl? Remember, HCl also, suppose if you take the example of HCl, when I'll add water, after adding into water, it will also produces H plus and Cl minus. This will also produces ions and it should conduct electricity. But remember, you should be very careful. This is dry HCl. It's not solution. After adding into water, then only it will produce ion. But this, you are taking your pure hydrochloric acid, it is gaseous state. It will not produce your H plus and its ions. That's why it will not split into its ions. That's why it cannot conduct your what we can say electricity. So based on that one, this C is the correct option for question number second. Question number second. Moving to next question. That is question number third. Question number third. The statement of the question is what happens when a solution of, now they are just I am underlining the solution of an acid. Now they have got acid solution. When you mix with, just you are adding, mixing means adding to a solution of base, that is like a thing is they have taken this acidic solution. So in a test tube, this is like a diagram of this test tube, rough diagram. So in this one, they have taken, this is containing a solution. What is that compound? It is acid. It is acid. This compound which are taken into a test tube, this is test tube. This solution is acid. Whatever it is present in this one, that solution is acid. Now what they are doing to that, they are mixing, they are adding to this, they are adding that is base solution. Now that is like compound also, it is base solution. To this they are adding base. Now already you have known, like when we have discussed, that is reaction. Suppose if I am taking example of acid as hydrochloric acid, and that is if I am taking base, this compound is acid, and if I am adding to this base is example I am taking, it is sodium hydroxide. Now this is base, and during like when I was discussing this your topic acids, bases and salts, when acids will react with base, it will give this compound will be salt plus water. And this reaction we are going to call it is neutralization reaction. This reaction we are going to call it is neutralization, and this compound it is going to be salt. And this reaction it is going to be called as neutralization reaction. Now this whatever the statement of the question is like same. You have got acid. This if I in this one whatever green colored in the test tube I have shown, to that you are adding. Suppose if I am showing with like what you can say black colored one, this compound it is going to be like it is your base. Then acid and base when they will react, it will form salt. And that is like this compound form will be salt. Now you have to check in out of the given like whatever Roman numbers they have written. So anywhere is a salt formation, it is going to be there. So this is going to be there, salt formation, fourth one. Now next, another three options are also there, just you have to see. And I think here just I am adding additional information, remember. So in chemistry, whenever you are reacting, that is a reactant, when they will react with each other, so depending upon like if you, it may be, now this reaction I said, this reaction between acid and base, it is neutralization reaction. So like that, suppose if I will take another example, carbon, when it will be reacted with O2, it will form CO2. It is combustion reaction. So these out of different reactions, some of the reactions are occurring, they are taking place with the liberation of heat. Heat will be liberated. Means heat will be given out. So such reactions we are going to call them as exothermic. A reaction which is occurring with the liberation of heat, it is called exothermic. Opposite of that one, if the reaction is taking place with the absorption of heat, it is called endothermic. Now remember, this combustion and this reaction between acid and base, it will be accompanied by liberation of heat. Heat is liberated. So that's why now you can see here, that is temperature of the solution decreases. So it cannot be. Heat will be absorbed means temperature will decrease. The temperature of the solution remains same. It cannot be the observation related to this one. Now another one, the first one, just you can see the temperature of the solution increases. So I said initially before mixing, temperature is around like what you can say, if you are performing at room temperature means it is in terms of degree Celsius is 25. When you are adding this like a base, that this reaction after taking place, that temperature definitely will goes like higher than 25 degrees Celsius. It will be temperature increases because that reaction is exothermic. So based on that one, related to this the first one, Roman number first and fourth, these are the two correct observations just we are going to make out, or we can see. So based on that one, for this question, that is option D is the correct option. It is 194, 194. Moving to next question. That is question number 4. Question number 4. So the statement of the question is, they have got an aqueous solution. They have got an aqueous solution means a particular compound, it is dissolved in water. So that is called aqueous solution. Now that aqueous solution, they are saying it will turns, it will changes this red litmus to blue. Red litmus to blue. So already for the first question, we had a discussion. Now, if any solution or compound, if it will turns red litmus to blue, that is, then that solution must be basic. That solution must be base or basic in nature. Now that is the thing, they are saying red litmus blue. Now what they are doing, whatever the solution it is there here, just if I am taking this test tube, that is this solution here, if I am writing with this one, this is showing with the color, different color. This solution is base. This solution is base because what is the reason? It will turns this your red litmus to blue. Based on that one, this solution which I have taken the test tube is going to be base. Now they are adding, that is excess addition of which of the following solution would, now they are adding, that is like they are asking, will reverse the change. Now meaning is, it is converting red litmus to blue. Now what we are supposed to observe, after adding which of these compounds, this blue litmus, it should turn to red. Means that solution is basic, it should changes, it should become what you can say acidic. Now basically that solution is basic. Now we have known already, earlier I have written one equation, that is, suppose if it is base NaOH, when you react with acid HCl, so it will form, that is what you can say, salt and water, and that reaction we are going to call it is neutralization. Now remember, that is, when you are adding, this is same mole and this is same mole, then that resulting solution will be neutral. Suppose they are adding here excess addition of out of this. Suppose if I'll add excess amount of this your HCl, then the solution will become what you can say acidic. Then that blue litmus paper will turn into red. So based on that one, out of these compound, which compound it is acid that you are supposed to identify, then we are going to say that is like that is going to be the correct option. So this baking soda is sodium hydrogen carbonate or sodium bicarbonate. So this is basic in nature. Lime water is calcium hydroxide. This is also basic. Ammonium hydroxide, this formula is NH4OH, which is also basic. So I have to add acidic solution. Now then remaining one will be this like hydrochloric acid is acid. So based on that one, so this after adding hydrochloric acid to the solution which is having like property to turn red litmus into blue, by adding excess of hydrochloric acid, blue litmus paper will turn into red. So based on that one, for question number 4, that is D option is going to be the correct one. Now moving to next. Question number 5. Question number 5. Now, what is the statement of this question? They are asking incorrect, that is means wrong, incorrect statement about which compounds they are asking, that is acids, that is maybe like one or more than one statement which is incorrect. Now suppose if you try to recall, I have given some of the characteristic properties of this, or what you can say, acids. So acids, when you taste, they have got sour taste, this is correct. Now definitely they will change, that is the color of this your indicator, this is also, it is going to be, this is correct, it is related to this one property of your acid. Now the change the color of, already in the previous question, if the solution is acidic, it will turn blue litmus to red, this is also correct. Now next is they change the color of, now this is already, this statement is correct. Now if you compare this C and D, exactly they are reverse, this is correct means this is going to be the wrong like what you can say statement. So based on that one, now the question they are asking which is incorrect statement. So out of these, A, B, C are correct, this is wrong, that's why this for question number 5th, D is the correct option, D is the correct option. Now moving to next question, question number 6. Now, the statement of the question is the acid used in making this vinegar is a compound that is going to be contain nearly, this vinegar is a compound that is, it is going to be used in like a preparation of some of the food items. So that is nearly 30 to 40%, 40% acetic acid. This vinegar is nothing but it is going to contain like 30 to 40% of acetic acid. Now they are asking the question, the acid used in making vinegar is, now already I have said, so based on that one, this is the correct option, acetic acid is the correct option. Okay. And whereas these two, we have known these two are, this your sulfuric acid and this your nitric acid, these are mineral acids. Now moving to next question. This is under reactions of your metals, acids and bases that we had a discussion. So how like acids and bases will react with like we have discussed metals and with your metallic oxides and all those things. Now if you see in this question, this whatever CuO, copper oxide, it is metal oxide. Generally metal oxides are basic in nature. Now whatever the equation they have given, chemical equation, this copper oxide by reacting with out of these four, which of the compound, it will produces copper sulfate and water. Now suppose if I'll go with one by one. So now this your, you take first one CuO, when you react with, if I'm taking copper sulfate as a another reactant, then you can see already product it is given. What is that product it is given? CuSO4. See, reactant also product, reactant also same, product also same, means this reaction it will not takes place. So that's why this cannot be the option. This cannot be the option. Next, if I am reacting this copper oxide with HCl, what we are going to get? We will get this CuCl plus H2O. Now, but what will require? Here will require copper sulfate. That's why with this it cannot give. Next, I'll go with another one, copper oxide plus what is that C option? It is there. It is sulfuric acid. If I am reacting it with sulfuric acid, then it will forms CuSO4 plus H2. Now you can see in this one, whatever this equation and whatever now I have written, both are same. In the place of X, what you got? This is your sulfuric acid. So based on that one, for question number 7, C is the correct option. Suppose if you want to write with nitric acid, CuO plus HNO3, just you can see, you will get CuNO3 taken twice, copper nitrate plus H2. So this is not there here. That's why this cannot be the answer. So based on that one, for question number 7, C is the correct option. C is the correct option. So moving to next question, that is question number 8. Question number 8. Now the statement of the question is, this juice, that is a gastric juice, which is found in your what you can say stomach. So what is the pH? How much it is going to be having? So that is the question. Now, before discussing that is like which is the correct what you can say answer for this question, let me go with here to express or to like what you can say find out this your strength of acids. Strength means all acids they will not have like what you can say same strength. Some of them are what you can say strong strength in the sense some of them they are going to be strong acids, and some of them they are going to be what you can say weak acids. Now based on that one, now to express the strength of acids, we are going to make use of a scale. So that scale we are going to call it is pH scale. pH scale. Now what is this pH scale? pH scale. Now remember, that is in this whatever this we have written, it is pH. That is, this is P stands for potence. That is, it is derived from your German word. And this your H, it is H plus ion concentration. Now pH is a scale that we are going to use for measuring strength of your what you can say like acids and bases. Now remember, first for different like solutions, like a pH will be measured starting from 0 to that scale will be there up to 14. This is scale which we are going to measure that pH of different solutions will be or compounds will be. It is going to range from 0 to 14. Now in that one, it has been divided into 3 parts. Now here I am making center one. Now center, if I am writing here 7, if I am marking. If for any solutions or any compound the pH is 7, then that compound it is going to be neutral. Above 0 and less than 7. Now if I am going to write here, that is like greater than 0, less than 7, then those solutions are acidic. Suppose if it is greater than 7, less than 14, then those solutions are basic. This we have already discussed. Now this is the like a pH scale. Now I am saying next once again, that is here, that is if it is the value of pH is smaller value. Now I am saying, suppose if I am going 0 to like not exactly 7 means neutral, 6.9. In that one, suppose if it is like pH is 1, then it is highly acidic. That compound is highly acidic or it is strong acid. Now suppose if it is 6 or 6.5, then it is like what you can say like a weakly acidic. So like this. Same way, suppose if the pH of that particular compound is 14, it is highly basic. If it is like 8, then it is like what you can say weakly basic. This point you are supposed to remember. If it is exactly 7, that solution will be neutral. Now coming back to that question statement, now pH of gastric juice released during the digestion is, means it is present in the stomach, which is helpful for digestion of this or whatever the food will take. So that solution, you should remember that gastric juice, it will be fairly acidic, weakly acidic. So based on that one, suppose if you go over here, if it is strongly acidic means or highly acidic means that pH must be 1, 2 like that. But it is fairly acidic means it is less than 7. Based on that one, for this question number 8, A is the correct option. Moving to next. Question number 9. Which of the following phenomenon occur when small amount of acid is added to water. I think during discussion of this your theory part, that is in one of my classes I've given, according to Arrhenius, acids are the substances when you take, just you take the acid, that compound, if it is acid, add water, after adding water, if they will produce H plus ions, then those compounds we are going to call them as acids. Similar way, if the compound it is going to, after adding water, if it will produce us OH minus, then that compound it is going to be base. That compound will be base. This already we have discussed. According to it is Arrhenius. Now they are saying that is generally, if I'll take one example of this one, if I'll take example of HCl only, when you add into water, after adding into water, it will produce us H plus. So now this is going to be called into Cl minus, into aqueous solution, into water, after adding water. Now this process we are going to call it is ionization. That is, a particular compound after adding into water, it will split into its constituent ions. That is called, that process we are going to call it is ionization. Now next, I am saying, suppose if I am saying this is pure hydrochloric acid, means it is around 100%. Pure HCl means it is 100% HCl. Now it is nothing there, it is pure HCl. Suppose if you add after adding H2, this hydrochloric acid, is it going to remain 100%? It cannot be. Definitely it is going to become, what you can say, it will become less than 100%. So now you can see the statement of this question. Which of the following phenomena occur, that is when small amount of acid is added to water. Now here just I showed here with some simple example of this your hydrochloric acid. Now what I said, when you after adding into water, it is ionizes into, it's like what you can say, constant ion. You can see this is like there. Now here after adding, there is no neutralization. This doesn't arises the question. Now definitely if you compare this 100 and less than 100, now this is diluted, this is concentrated. That's why this dilution it will take place. Next, now here there is no like salt formation because just we added into water. So based on that one, for question number 9, that is this 1 and 3, these are the correct, what you can say, that is like means like observation we can make out when you add, that is acid into water. So based on that one, for this question, B is the correct option. Now moving to next question, that is question number 10. So the statement of the question is, what it is stating, which of the following statement is correct? Now they are asking, right, about for which one? They have taken aqueous solution of an acid, aqueous solution of an acid, and that is of a base. Now I am reading once again the statement. Which of the following statement is correct about an aqueous solution of an acid and aqueous solution of base? That is the meaning. Now they have taken, that is acid, and they have added, that is, I can write like this way otherwise, acid, that is added water, and they have got, what you can say, base, same base to this also, that is they have added water. So it will become, so what you can say, it's aqueous solution. Now related to this, what is the, like, what you can say, which are the statement it is going to be correct? Now remember, already we had a discussion. If the compound is acid, when you add, according to Arrhenius, it should produce H plus into water. This I am writing it is into aqueous. Suppose If it is base, it should produce what you can say definitely OH minus after adding into water. Now, here whatever that option they have given, that you can see, higher the pH, stronger the acid. Now, acids, they will produce H plus. And already I said, pH is a scale. pH is a scale that is used to measure what you can the strength of your acids and bases. Now, how we are going to define this is log 1 divided by H plus ion concentration. It is a measure of concentration of H plus. What is that one? It is pH. It is pH. This now you can see relation pH and H plus. They are going to be inversely. This is greater. This is more. Concentration of H plus is more. Then this pH will be less or pH will be smaller. On the other hand, if this is less, if this is smaller, now this will be what you can say greater. This will be greater because these are inversely related. Now this pH and this your H plus ion, they are going to be inversely related. So because of that reason, we are going to say this one. Now you can see, suppose if the pH is higher, pH is more, already I have said that acid will be what you can say stronger. Now you can see here, higher the pH, higher the pH, stronger is the acid. Is it correct? Because you can see pH, even if you are not getting this one, I said that like a scale to measure your pH. I can write at this side. That is, it is 0 to 14 is a scale. 0 to I can rub here, otherwise I can write here. So this is a pH scale 0 to 14. Now here on this scale, that is 0 to 14 means it will be increasing. Now here this side it is acidic, and this side is going to be basic, and exactly at the center it is going to be neutral. It is going to be neutral. Now based on that one, more the pH value, stronger is the base. Smaller the pH value, stronger is the acid. Now you can see, higher the pH, stronger the acid. It cannot be. Higher the pH, stronger is the base. That's why this is not a correct statement. It is not a correct statement. It is, which is this statement 1. It is incorrect statement. It is incorrect. But they are asking correct statement. Now higher the pH, that is weaker the acid. Higher the pH, weaker the acid. This is also not going to be the higher the pH, weaker is the acid. This is correct. If base is stronger means acid must be weaker. So that's why this is going to be the correct statement. When you go to the next one, whatever the statement they have given, lower the pH means pH value will be smaller. Stronger is the base, it cannot. Lower the pH, stronger is the acid. That's why this cannot be the option. Now lower the pH, weaker the base. Definitely pH value is less, base will be weaker. So this is also going to be correct one. Now based on that one, in that given options, you can see that is second and what you can say fourth. These are the correct statements. So out of the given A, B, C, D, this is going to be the correct option. D is the correct option. Now let us move to the next question. That is question number 11. Which of the following is not a mineral acid? When we discussed about classification of acids, just as I said there, that is two types. One, that is acids. There are two types. One is mineral and another one is organic acids. So the acids which are obtained from your living things, it may be plant or animal origin. So those we are going to call them as organic. If they are other than organic, then they are going to be mineral. Now you can see here, this hydrochloric acid, sulfuric acid and nitric acid. These are like what you can say mineral acids, whereas the citric acid, It is going to be like found in your lemon. That's why it is going to be what you can say. That is now the question they're asking, not a mineral acid. All these three, which one? This hydrochloric acid, sulfuric acid, and nitric acid. These are mineral acids, whereas this is not. This is an organic acid. This compound, this is acid, of course, which is organic acid. That's why this is going to be the correct option. Let us move to the next question. Question number 12. Question number 12. What is the statement of this question? I think it is already, we have discussed such type of question in today only, previous questions. A solution turns red litmus to blue. Its pH is likely to be. Now they are saying they have got a solution that will turns red litmus to blue. So already we had a discussion. If the solution is basic, or if it is base, then it will turn red litmus paper into blue. Now based on that one, the question they are asking is its pH. How much is the pH it is going to be? So now everybody are aware on the pH scale. If that solution, if that particular compound is basic, means it should have pH above 7 and like up to 14. Now you can see this is 1, 4, 5. These are below 7. These cannot be the options. Now remaining one, it is 10. It is above 7 and below it is going to be 14. That's why for this whatever question number 12, that is D is the correct option. Moving to next question, that is question number 13. Now the statement of the question is they have got the sodium hydroxide solution. How much it is? 10 ml. 10 ml solution of sodium hydroxide is found to be completely neutralized by 8 ml of that is HCl. Now they have got two solutions. One is sodium hydroxide and another one is hydrochloric acid. Now we have already known in one of the questions, just we had a discussion. So when these two will react, that is like your NaOH and HCl, so it will give this your salt, sodium chloride and H2. This we have known, and this reaction we are going to call it is neutralization. Now they are saying that is to neutralize 10 ml of this solution. Which one? Sodium hydroxide. If I have got 10 ml, then how much HCl it is going to be like required? That is 10 ml of solution of sodium hydroxide found to be completely neutralized by 8 ml of HCl. Or you can take another way also. To neutralize 8 ml of HCl, how much ml of this your sodium hydroxide is required? 10 ml. Now they are saying if you take that is 20 ml of this one, instead of 10, you have to take, like I am writing here up 20 ml. 20 ml of the same solution of sodium hydroxide. The amount of HCl what you can say solution required to neutralize it will be, once again they are saying same HCl. Now you can see it is very simple. If I am going 10 ml requires 8 ml. Now 20 ml it is how much? 20 ml it is going to be how much? That is, you can go for applying this your mathematics. 10 divided by 20 divided by 10 multiplied by 8. Just to cancel this one. 2 0 0 it will get cancels. We'll get 2 8 is 16 ml. 16 ml. Now you can see in the given option D is the correct option. Now for question number 13, that is D is the correct option. Now moving to question number 14. Now the statement of the question is when small amount of acid is added to water, when you take, that is here, if I am drawing this one, once again this rough diagram. Now if I am taking for example, this is beaker. This is beaker. Okay. Now you can see, I can make here with a mark like this. This you, whatever this red color thing just I'm showing, this is water. This is H2. H2. A small amount of acid is added. Now you are going to add acid too. Now this is water. To this, what I am doing, I am adding that is acid. For example, my convenient, I am taking once again the example of that acid will be HCl. 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 Now they are asking what phenomenon it will occur when you add this HCl into water. Now definitely maybe one of the question in the same today only just we had a discussion. Suppose if I have got this concentration of HCl, whatever I'm adding, it is like 50%. 50%. You assume that after adding to water, what will happen to its concentration? Definitely it will reduces. It will become dilute. That's why if you see in the given whatever A, B, C, D, that is like dilution, it will take place. That is correct. That phenomena we can notice. Now here when you add HCl into water, this cannot occur. That neutralization will cannot occur. Now even D also it cannot be, because there is like this acid we are adding water cannot be like your base. So neutralization reaction will not take place. Then remaining formation of H3O plus. Now if you see, I am writing here that reaction HCl we have taken. When you add into water, of course, in earlier we have said this is going to dissociate into, that is H plus Cl minus. Of course. Now what will happen? This water, it will take this your H plus, this will take this your H plus and it will form, it will convert into H3O plus, H3O plus. So based on that one, this formation of H3O plus also, both this dilution and this your formation of H3O plus, this will be observed. So based on that one, for question number 14, A is the correct option. A is the correct option. Now moving to next question. Question number 15. Antacids contain. Now earlier, nowadays we have got a very good number of what you can say antacids with the different names in the market. But before invention of these, so generally they used to use this your what you can say hydroxides of this your metals. For example, this your magnesium hydroxide, MgOH taken twice. This solution they used to use as a what you can say antacid means the substances which can react with your acid, or whatever the excess secreted acid is going to be neutralized. So those compounds we are going to call them as antacids. Now those must be, this compound it is basic. That's why that is these should be weak bases. So based on that one, for this question, question number 15, A is the correct option. Antacids are generally weak bases, weak bases. Now moving to next question, question number 16. The correct statement regarding universal indicator. Now these indicators they will what you can say show the endpoint. Now related to them, and like we have got different types of indicators. So maybe in detail we are going to discuss when you will join for like PU first year. So that time. Now generally like this is a property of this or universal indicator is it will give like what you can say orange color when the pH of this your solution will be like what you can say equals to 3. So based on that one, for question number 16, D is the correct option. Now moving to next question number 17. The statement of the question is the pH of a solution they have given. pH is how much? A solution they have got, its pH is 4. What should be the change in the hydrogen ion concentration of the solution if its pH is increased to? pH is increased to. Now they have got some solution is there. Just I am writing here solution whose pH is how much they have given. Just I am mentioning it is pH is equals to how much they have given, it is 4. 4. Now next part, what should be the change in the hydrogen ion? Because already I have said this pH definition itself, it is a measure of hydrogen ion concentration. I can write like this: log of 1 divided by H plus ion concentration. It is a measure of hydrogen ion concentration. Now remember, already earlier today only, just while discussing some other question, just I have given that information. This pH and H plus, they are going to be inversely related. Now you can see first pH is 4. Now if its pH is increased, what they did, that is like they have increased it to 4 to how much they have made it is 5, means it is increased. Now how this pH and H plus they are related, earlier also I said inversely. If pH is increasing, means H plus ion concentration should decrease. It should be decreased. So based on that one, you can see almost, that is, it is a one unit it is changed, is it? Means like 10, almost 10 times. Just we are going to like what you can say, its concentration should be that is means hydrogen ion concentration. pH if it is increasing, means hydrogen ion concentration should be what you can say 10 times decrease. So based on that one, for if you see the question number 17, that is the concentration. Now it is not exactly half, it is not double, it is increased. I am saying it should be decreased. Decreased where it is given, this is increased, it cannot be the option. It is half, it cannot be the option. Double also, increased it will become, it cannot be the option. Decreases here it is given. Now you can see to 1 by 10 of its original concentration. So for like whatever pH change by 1 unit, its concentration should be like what you can say, if the pH it is increasing, concentration will be 10 times decreased. If it is like a pH will be decreased by 1 unit, a concentration should be increased by what you can say 10 times. That you are supposed to remember. So based on that one, for question number 17, that is what you can say, A is the correct option. A is the correct option. Moving to question number next, 18th. Here once again it is related to pH. pH of a solution is 5. Its hydrogen ion concentration is decreased by 100 times. Now earlier I said, so in the previous question, if it is increased 4 to 5, how much is the increased unit? Increased by 1 unit. 1 unit. Then concentration, it is how much decreasing? That decrease in concentration, I can write decrease in H plus ion concentration. H plus ion concentration 1 divided by 10 times. 1 divided by 10 times. 10 times. Now here they are saying, it's if the pH of the solution is 5, its hydrogen ion concentration is decreased. Now that is, now they have got, just I am going to write it here, pH is how much? 5. Now once again I am writing the definition of pH. pH is equals to log 1 divided by H plus. They are inversely related. Now pH is 5. Now what they are doing? They are its hydrogen ion concentration is decreased by 100 times. Now concentration of H plus ion is decreasing, then what should happen? pH must increase. pH must be increased. So based on that one, we can say that is pH if it is like 5, by decreasing that concentration, pH should increase by 10 times, means 1 unit. Now it is like they are saying 100 times, 10 times, then it is what is happening? It is going to increase. So based on that one, that solution it will become what you can say, that is a more acidic, it should become basic, because pH it is going to be increasing. So based on that one, for question number 18, that is this B option is correct. Once again I am repeating, pH they have got 5. Now what they are doing? The hydrogen ion concentration, they are decreasing this H plus ion concentration. Then what will happen to the pH? pH it might increase. More than 5 it will becoming, then that solution will becoming what you can say, it is going for what you can say basic region. So next, question number 19. During the preparation of HCl, that is hydrogen chloride, means your HCl gas, on a humid day, means like suppose where that that is a environment, or that is like atmosphere, it is what you can say it is having moisture. So a gas is usually passed through the guard tube, which is containing calcium chloride. Calcium chloride. Suppose some moisture is entering into that river. If you want to prepare this HCl, it is only HCl. It is 100%. 100%. Okay. But whatever the area we have got there, it is going to be like having like some moisture content. In that case, this HCl, it will take that moisture. To avoid that one, they are using this your like a tube that is like it is made up of glass, that will they will fill with calcium chloride. And the role of this calcium chloride, it will absorbs whatever that moisture it is present in the environment. So based on that one, now you can see the role of calcium chloride they're asking. It will absorb, already I've said, moisture which is present in the environment. So just given options you can see, absorb, this cannot be, that HCl gas it cannot absorb. That is moisten the gas. It cannot it will not become, it will not allow the hydrochloric acid to become wet. That's why it cannot be the option. Absorbs, you can see here, absorbs the moisture from the gas. Whatever that is like very small amount of water will be there, means it can absorb. So that's why this is going to be the correct option. So based on that one, that is for question number 19, that is C is the correct option. Moving to next question. That is question number 20. Question number 20. So the statement of the question is sodium carbonate is a basic salt because it is a salt of. Now remember, that is generally, suppose if I'll take the example of this salt, common everyone knows, this is a sodium chloride. Now we cannot say, if you take a salt, when you add water, I cannot say all the salts are neutral. Depending upon, after adding water, what they will convert. Now if I'll take simple sodium chloride, when you add water, it will forms two compounds. One is NaOH. This Na will combine with the OH of this your water, plus it will form another compound, that is HCl. Now remember, both this is also strong and this is also strong. They will like what you can say dissociate completely, and that resulting solution will be neutral. That is neutral. So that's why the sodium chloride will be neutral. Suppose, if I'll take another example. For example, another one, if I'm taking this ammonium chloride. Now, when you add water, suppose if I'm adding here water, now what will happen here? This ammonium will combine with OH of your water and it will form ammonium hydroxide. What it is going to remain here? HCl. Now you should remember, this is strong, whereas this one is weak. So this will dissociate completely. This will dissociate partially. That's why this solution will be, whatever ammonium chloride solution will be acidic. Now based on that one, you should remember, when you take salt, after adding water, what it is going to give. Based on that one, we are going to say whether that particular solution of that particular that salt is acidic or basic. Now here they are saying sodium carbonate is a basic salt. It is a basic salt because now that you are supposed to, if I'll take sodium carbonate formula, what is that formula of sodium carbonate? This is sodium carbonate, Na2CO3. Then you add water. Now what will happen? Just I'm writing it here. So I'll remove this one. It will produce us this Na. It will combine with your OH of water and it will forms NaOH. Plus this CO3, it will combine with H. It's going to convert into H2CO3. Now remember, out of these two, this is sodium hydroxide. This compound we are going to call it is carbonic acid, like how hydrochloric acid and all. So this is not stable. So that's why this compound, it will dissociate. Sodium hydroxide being a strong base, it will dissociate into its ions, and because of that reason, this whatever sodium carbonate it is what you can say, that is basic. What is the reason? Because it is made up of strong base, and what you can this is like a weak acid, I can say, even unstable, and it is a weak acid. Now you can see in the given option, strong acid and strong base. This cannot be the answer. Weak acid and weak base, it cannot be. Now strong acid, strong, if it is acid is strong and weak is base, means it will become acidic. Now weak acid, this is like acid is weak. If I am writing Wa means it is weak acid, Sb means it is going to be strong base. That's why it is going to be basic. So based on that one, this question D is the correct option. D is correct option. Now next, question number 21, the statement of the question is, this is calcium phosphate. This is a compound which we are going to like what you can say present in your tooth enamel. Its nature is, what is the nature of that compound? They are saying it is, that compound is chemically, it is basic in nature, Now moving to next question, question number that is 22. Common salt besides being used, that is like of course sodium chloride is used in making used in the kitchen for different like preparing food items. It is used as a raw material for making already compounds of sodium chloride. We had a discussion using this sodium chloride we can prepare. First I have given that is compound is sodium hydroxide we can make, and using this we can prepare your sodium carbonate Na2CO3, we can prepare your NaHCO3. So that is the thing, it is raw material for making this sodium hydroxide, sodium carbonate, sodium bicarbonate. Now washing soda is this your sodium bicarbonate, this can be prepared by using that one. And next, that is baking soda. Baking soda, it is what you can say, sodium carbonate is washing soda, baking soda is sodium bicarbonate. So based on that one, for this question, third option, C is the correct option. C is the correct option. Now don't get like here, bleaching powder, it is not directly prepared from your sodium chloride, but one of the byproduct it is obtained during the production of sodium chloride, sodium hydroxide by sodium chloride. So chlorine, that will be used for making your bleaching powder. Moving to next, question number 23. You have 4 test tubes A, B, C, D containing sodium carbonate. So now sodium carbonate is there in test tube A. Sodium chloride is there in B. Now lime water, it is calcium hydroxide, it is in C. And D contains what you can containing, that is blue litmus. Sorry, just I am repeating once again. We have 4 test tubes. Suppose if I will label like this here, 1, 2, 3, 4. Now they are saying containing sodium carbonate, sodium chloride, lime water, and blue litmus solutions respectively. Now here this has got sodium carbonate, Na2CO3, CO3. This has got NaCl. This has got CaOH taken twice. Now here it has got blue litmus, blue BLL, right? Out of these, the material of which test tube would be suitable for the correct test tube, this your acetic acid. Now they are asking in test tube, first you have got sodium carbonate, that like sodium hydroxide, and here it is going to be calcium hydroxide. Now out of this and the last test tube, it is containing blue litmus paper. So out of these, which one it is going to be suitable? Now remember, already we have known, suppose if this, because this acetic acid is acid, so acid, if it is solution is acidic, then blue litmus paper, Bl means blue litmus paper, it will turns to red litmus paper. So definitely this fourth, it is going to be useful. And other than that, that is now acetic acid, you should remember. So it can react with what you can say out of the given, you can see sodium carbonate is a weak base. So this acetic acid also weak, it cannot. And suppose if you take that is sodium hydroxide strong base, acetic acid, it can react, acetic acid it can react, and calcium hydroxide cannot be. So based on that one, for this question number 23, so this blue litmus paper, it is going to be helpful, and that is what you can say, it can react with your that is um, sodium carbonate. So question number 23, D is the correct option. Next, moving to question number 24. Baking soda is a mixture of sodium carbonate and acetic acid, sodium carbonate and tartaric acid. And now it is baking soda, already formula I have said, it is going to be sodium hydrogen carbonate, sodium bicarbonate, and they will add a little bit of this tartaric acid. So based on that one, for question number 24, this is like C is the correct option. Next question, that is question number 25. The chemical formula of plaster of Paris, that is like calcium sulfate, it is half water molecule. So this is that is what we can say plaster of Paris, POP, that we are going to use in what you can say construction of that house for interior designing purpose. So that has got the formula will be basically calcium sulfate, and it is going to be half water molecule. So this is going to be the chemical formula. Based on that one, C is the correct option. Now this is the last question. This is the last question. So like these are some few sample examples of question. Probably they can ask based on that is like what you can say the topic uh, acids, bases, and salts. So like that you can practice some more questions. So similar to this, so you can like if you get some questions in your entrance exam, so you can easily solve. So thank you.